Good afternoon, everyone. We are from Group 1. We are here to present the stormwater management infrastructure by using the software FLO-2D. Below are the members. Now, I will pass to Chishan for the first slide.
So the first slide is about the objective. Our objective of this project is to reduce the flooding problem in Taman Sri Kulim in Kedah. The other one is we want to study the factor that causes the flood in Taman Sri Kulim in Kedah. Another, we will use the FLO-2D software to determine what is the reason and what is the causes and how do we solve the problem on the particular site, which is Taman Sri Kulim in Kedah. So the next is the Gantt chart. So you can see that our planning and our actual progress is quite different, which we have a lot of crashes on timeline, also on schedule, that will cause our dragging our time, which is we have a team building day for feedback. And another thing that you can see is our site visit. We went for 4 times to Kulim because of we are lacking of some data, and also we went to JPS like twice time to get the data on it. So the next, it will be the location map. This is the location map of our site, which is Taman Sri Kulim. So you can see that is nearby Kulim. Yeah. So the methodology side, I will pass to my colleague Atong to say about it.
Our project is kickstart with a brief meeting. Afterward, we do some preparation before go to site visit. We borrow leveling apparatus from our school office, and then we go to site visit. We measure the height and topography of the site, and we went some government agency to collect some data, and we can get some data from the GIS. Afterward, we have data analysis using FLO-2D, and then is presentation, which is now, and afterward we have reporting.
Okay, next is my part. I'm going to tell about what is the use of the FLO-2D. FLO-2D is a flood routing model, stimulates channel flow, unconfined over land flow, and straight flow over complex topography. Another use of FLO-2D is a physical model process the roads, rainfall runoff, and flood hypographs over unconfined flow surfaces or in channels using the dynamic wave approximation to the momentum equation. The results of the FLO-2D is to predict the flow depth and the velocity. So next is about the case study we study in Taman Sri Kulim. So based on our case study, flash flood are often occur in Taman Sri Kulim. On 10 December 2010, the government has taken some action on this issue by building a retaining wall at the Sungai Tebuan. However, the initiative does not succeed eventually. On 29 August 2013, Taman Sri Kulim are hit by a flash flood due to heavy downpour affecting 200 houses with 1.2 meter floor height. This is the flood spot in the Kulim. Next, we are going to site visit. So based on our site visit, there are some high wall beside the house is to prevent the flood water enter. Another thing we observe is the spoiled drainage system. So this is some picture on Taman Tasik Putra Kulim and Sungai Wang Emas, which near to Taman Sri Kulim. So based on our observation, we observe that there are lack of maintenance happen on site. So another thing is, this is the rainfall data we collected from the Department of Irrigation and Drainage, or in BM called Jabatan Pengaliran dan Saliran in Kulim.
We calculate the peak discharge of Taman Sri Kulim based on the equation Q equal to CIA. And Q stands for the maximum rate of runoff, C stands for runoff coefficient, I stands for average rainfall intensity, and A stands for drainage area. From the data we get, the runoff coefficient area is 0.8 because the Taman Sri Kulim is a rural area, and the average rainfall is 18 mm per hour. Drainage area we stand for 5% of the total area of Taman Sri Kulim, which is 1434.335 square feet. Then after calculation, we get the result, the peak discharge of Taman Sri Kulim is 0.053 meter cube per second, which is much lower than the standard one. So this caused the flash flood in Taman Sri Kulim.
So this is my part. So for the simulation FLO-2D, so I will present some data on the practice. So the first on that, we will open the menu and see what data is required. So basically we will see through all the introduction. So after that we will go to a data requirement. So you can see that if you want to getting start, the following step is needed to complete, which is this thing. If you didn't complete this step, that you were unable to run the FLO-2D application. So now I pass to the FLO-2D application. So first thing, we will open the file and we find the new project, and what we do is we have the existing shape file that we get from the GIS, which is we open the GIS with the VirtualBox. So after that we will open from here to so basically this is the shape file already. So the next thing is we will design our elevation point. Is we will insert, like if our elevation point is 1 meter, so we will just click 1 and then OK. So we will click in our site, which I already click on that, so I will click outside of my site so that the result won't be affected. So it's put like that. So this is 1 meter elevation. So if you want to add on for the another elevation, you have to insert. Let's say it's a 3 meter, so you have to open is 3 meter. So you will continue click. So you have that's something like contour model, but in design with the FLO-2D application. So the next thing we want to open is we will go to tools and go to hydraulic structure. For the hydraulic structure, we will create a new inlet and outlet grid element, which is with this thing, so we will know the inlet and the outlet of the site. So one thing that I missed out is before all the things happen, we have to create a grid. So the grid is determined on the size. So for our size that you can see from here is 100 meter. So this is when you click OK, so it will come up like this. You can see from here the grid is now ready. So after that we will try to run the FLO-2D, which is the simulation time is 0.5 hours. The output interval also 0.5 hours. So now we are starting to run the FLO-2D to see the result. So this is our result. So it determined that the overall performance of the site is excellence, which is no net action is necessary. However, the simulation result is different from what we observed from the site visit and also the calculation from the Q equal to CIA, which is the peak discharge. So we found that something different from this. However, we still think that is the need to have the improvement on the site itself for the flood, to avoid the flash flood happen in the selected site again. So this is the simulation from the FLO-2D application. The next thing is about a suggestion that we want to apply to the site. So this I will pass to my colleague.
Okay. There are a few suggestions that we propose in the Taman Sri Kulim. At first, we would like to propose a retention or detention pond in the Taman Sri Kulim. There are two types of ponds that are often used in flood control. The first one will be the wet pond, or also known as the retention pond. The next will be the dry pond, also known as the detention pond. But for our site, we choose to use the retention pond because at the end of the Taman Sri Kulim, there is an undeveloped area which is suitable to propose this retention pond. The retention pond is functioned as a storage for the stormwater runoff. It will also settle the suspended sediments and other solids typically present in the stormwater runoff. Next. The retention pond also will provide a pollutant removal through the settling and the biological updates. It is shown that the pond can remove up to 30 to 80% of the pollutants from the water before it enters to the nearby stream. And this is the picture for the retention pond. Next, we would like to propose the rain garden. Rain garden is usually located beside the road and also below the rooftop. It improves the water quality by filtering the runoff. The rain gardens can also cut down the amount of pollution reaching creeks and streams by up to 30%. It provides a localized flood control and which are aesthetically pleasing and also provide interesting planting opportunities to the residents. Below are the rain gardens of the picture of the rain garden and how it works. The last suggestion we would like to propose in the Taman Sri Kulim is to have a permeable pavement. The permeable pavement with a base and sub-base that will allow the movement of the stormwater through the surface, which will not let the water accumulate at the site and will not causing flash flood. In addition, to reduce the runoff, this effectively traps the suspended solid and also filters the pollutants from the water. The permeable paving surfaces keep the pollutants in place in the soil or other material underlaying to the roadway. And it also allows the water seepage to groundwater recharge while preventing the stream corrosion problem. And these are the pavement and how the pavement works. And that is all from us. Thank you.